Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 12 in the Broken Access Control module titled Multi-Step Process with No Access Control on One Step. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select access control, and then go down one last time and select lab number 12 titled Multi-Step Process with No Access Control in One Step. Alright, let's get started. This lab has an admin panel with a flawed multi-step process for changing a user's role. You can familiarize yourself with the admin panel by logging in using the credentials administrator admin. To solve the lab, log in using the credentials for this regular user over here and exploit the flawed access controls to promote yourself to become an administrator. Alright, so the target goal for this lab is to exploit a multi-step process in the way that you could change a user's role and then use it in order to promote yourself to an administrator user. So let's access the lab. And notice over here, I'm using the built-in browser in Burp, and so all my requests are already going through my proxy. All right, the first thing that we're going to do is log in with the administrator account to see how that functionality works. So the username was administrator, and the password was admin. And then we're going to click on admin panel. And here's the functionality to upgrade a user or downgrade a user. So we need to upgrade our own user, but we need to do that through exploiting a broken access control vulnerability. And so to check how the functionality works, we're going to try and upgrade the Carlos user. So we click on upgrade user. This is the first request that it makes. Let's send that to repeater. And then it asks you if you're sure that you want to upgrade that user. You click on yes. And this is the second request that it makes, and so we'll send that to repeater as well. So over here, this is called a multi-step process because there's multiple steps that you perform in order to finish your end goal, which is upgrading a user. The first step over here is to the /admin roles path. It takes in the username of the user that you want to upgrade and then the action that you want to perform, which is upgrading a user. And then in the second step, it's to the same path as well. And it's a post request, except with this one, you confirm that you really want to upgrade that user. Now, this is a really good example because I see vulnerabilities in multi-step processes in a ton of the applications that I test. And the reason is because most developers assume that if you put access control on the first function, then you don't need to put access control on the second function, which is this one over here, because a regular user would never get to this request unless they've gone through this request. However, that's not how requests work. Hackers can call any request that they want, and so access control needs to be implemented on every request that the application makes. But we still don't know that this is vulnerable, and so let's log out of the admin account and log into the regular account that we were given. All right, let's click on my account and log in with the credentials that we were given. The password was Peter. Hit login. And then what we're going to do is we're going to click on inspect and then application and then extract the cookie for this user. So this is the cookie that identifies the regular user. And then we're going to try and see if we can use the regular user cookie to perform admin functionality. So if we hit send on the first step in the multi-step process, it says it's unauthorized, which means that proper access control rules were put on this specific step. Next, let's check the second step. Hit send, and we get a 302. If we follow redirection, you could see that we get a 401 unauthorized message. So that's interesting. I wonder if it's because we're trying to upgrade a user that is not us. So let's try and upgrade the user that is us. Let's do that for the first one actually as well. Confirm that we still get the unauthorized message. Hit send. It's still an unauthorized, and then for the second one as well, hit send, and click follow redirection, and here we go. It says congratulations, you solved the lab. So again, what likely happened is that the developer put access control rules on this specific item over here, assuming that you can get from step 0 to step 2, you have to go through step 1. And if you went through step 1, then you have the proper access to perform this functionality. However, again, this is not how requests works. We could perform any request in whatever order that we want, and that's essentially what we did over here. If we directly just perform this request, it upgrades our own user to an admin user. All right, so we've successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Let me make that a little bit bigger so that you guys could see it. Now, as usual, we'll import the libraries that we need. So the requests library, the sys library, the URL lib3 library, and the beautiful soup library. So from BS4, import beautiful soup, and then the regex library. And we're going to disable insecure request warnings. So disable warnings, URL lib3 dot exceptions dot insecure request warning. And we're going to set our proxy setting because we want all of our requests to get sent through burp. So we'll send all HTTP traffic to where burp is installed, which is 127.0.0.1 port 8080. And we'll send HTTPS traffic to the same location. So HTTP 127.0.0.1, and again on port 8080. All right, this looks good. Next, let's create our main method. So if name is equal to main, then call the main function. In the main function, as usual, the first thing that we're going to do is we're going to check if the command line arguments is equal to 2. And if it's not, is not equal to 2. And if it's not, then we'll print the usage instructions, which is the name of the program, and then the URL. And we take in the name of the program from the command line argument. And then we'll also print example instructions just so that it's absolutely clear how to run the program. All right, and then we exit the program because the user ran it incorrectly. Now let's assume the user did run it correctly. If so, we'll start off by creating a sessions object that will be used to perform requests. So request.session, and then we'll create a variable called URL, and we'll take the URL from the second command line argument, and then we'll call a function called upgrade the regular user's account, and it takes in the session object and the URL. All right, so this function is going to perform our exploit for us. So let's define it right over here. So def upgrade function, and it takes in the session object and the URL. The first thing to do is log in as the regular user. And to do that, we need the login URL, which is equal to the regular URL plus the path /login. Next, we need to know which parameters are taken in the login request. So if we go over here and we look for the post login request, you could see the path is /login. It's a post request, and it only takes in 2 parameters, the username and the password. It does not take in a CSRF parameter, and so we do not need to extract the CSRF token from the previous request. So we'll save the parameters in a variable called data login. The first one is the username, which is just the regular username, and then the password, which is also just the password that we were given. And then we simply perform the request. So R is equal to s.post because it's a post request, takes in the login URL. Data is equal to data login. Verify is equal to false because we don't want to verify TLS certificates, and proxies is equal to proxies because we want to send the request in Burp. Okay, next we're going to set the response to a variable called res, and then we're going to say if logout, so the string logout is in res, then print successfully logged in as the regular user, otherwise print could not log in as the user, and exit the program because if we can't log in, we can't exploit the vulnerability. All right, so let's assume that we successfully logged in as the user. The next step is to exploit the broken access control vulnerability and upgrade the user to administrator. So we're going to print another statement saying upgrading user to administrator. And to do that, we need to understand how that request works. So if we go back to repeater over here, it was the second request that was vulnerable, or the second step in the multi-step function that was vulnerable. It's a post request. It is to this path over here. So let's copy that. It takes in three parameters: the action parameter, the confirmed parameter, and the username of the user that we want to upgrade. So let's put that over here and start writing our exploit. So the first thing is we need the upgrade URL, which we just copied. That's the URL plus admin roles. Next, we need the data for the request. So like we said over here, that was action. So let's add action. And that was equal to upgrade. And then we had confirmed. And that's equal to true. And then we had username. And that's equal to the username that we were given. And that's pretty much it. Now we're ready to perform the request. So R is equal to s.post because it is a post request. It takes in the upgrade URL. And then we're going to say data is equal to data upgrade. Verify is equal to false. And proxies is equal to proxies. And then we're going to say if r.status code. So the code for the request, once it's performed, is equal to 200. Then print successfully upgraded user to administrator. Otherwise, print could not upgrade user to administrator, and exit the program since our exploit didn't work. All right, this looks good. So essentially over here, you do get a 302, which is a redirect. However, when you perform a request over here, unless you say do not allow redirects, it will follow a redirect. And if you follow the redirect over here, it was a 200 OK response after that. And so we're looking for a 200 message. If you don't get a 200 message, so if you get like a 401 unauthorized, that means your exploit didn't work. But if you do get a 200 message, that means the exploit worked. All right, that's the end of the script. Let's save it. So if we review it, and let's make it a little bit smaller so that we could see the entire script. Essentially, We first create the main function. If the user runs it correctly, it calls this function right over here. And in this function, what it does, it logs in as the regular user account. And from there, it exploits the broken access control vulnerability in order to upgrade the user to an admin user. Hopefully there's no errors in the script. So let's run it and confirm that. Access control lab 12.py. And our application likely timed out, so let's open it up again. Let's copy the URL, paste it here, and remove the trailing slash, and hit enter, and we do get an error. So if we go to line number 26, this should be equal to. All right, this should fix the error. Hit enter again. And here we go. It says, congratulations, you solved the exercise. All right, so we successfully completed the exercise by first exploiting the vulnerability manually and then scripting it in Python. In the next lab, we'll look at one more case of broken access control vulnerabilities before we end this module.